Trig Chapter 5 review. So this is the first part is just review. You don't have to write anything. You just have to pay attention. So sine and cosine functions are periodic or sinusoidal functions. The values of these functions repeat in a regular pattern. These functions are based on the unit circle. So consider the graphs of y equals sine theta and cos theta. So this is sine theta over here. And then this is cos theta. They look the exact same except what? What would you remember? What's the difference between them? Yeah, this should be next one. The difference between them is a horizontal shift. So if I take the sine graph, you guys, if I take the sine graph and I move it pi over 2 to the left, it's actually the cos graph. Or if I take the cos graph and I move it pi over 2 to the right, it's the sine graph. It's just a C shift, right? So when I ask you to find the sine equation or the cos equation of a graph, the A's are the same, the B's are the same, the D's are the same. The only thing that's different is the C, remember? So you can find the A, the B, and the D all the same way. This is a basic sine and cos graphs. The maximum value is +1, the minimum value is -1, the amplitude is 1 because amplitude is half the distance from the min to the max, right? And the period of this graph is how long it takes to repeat itself, which is 2 pi for both of them. The y-intercept is at 0 on this one. The y-intercept is at 1 on cos. The theta intercepts in the given domain are -pi, 0 pi, 2 pi, 3 pi. And for cos, they're -pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, which makes sense because on the unit circle, cos is, it has x-intercepts at -pi over 2, pi over 2, 3 pi over 2, or 5 pi over 2. The domain is theta ER. The range is from -1 to 1. So do you remember how a quick way to find the range? Remember your range is y such that min is less than or equal to y is less than or equal to max, YER. Off the graph, you'd literally just look for the min and the max. We agree? But off of an equation, how do we find the min and max? Do you remember? No, remember on your calculator, you can only punch in your calculator if you have one missing variable. What if I put in like 4? How do you do your min and your max? Your midline, which is your D, plus your amplitude, it's your max, and your D minus your amplitude gets you your min. So this is D minus amplitude, and this is D plus amplitude. It makes sense because in this case, my D is the center, my D is the midline. So in this case, it's y equals 0. If I count up 1, I get to a max. If I count down 1, I get to a min. So if I take the D and I add my amplitude, amplitude being 1, I get to 1. If I take the 0 and subtract my amplitude, I get -1. Okay, for sinusoidal functions of the form y equals a sine bx or y equals a cos bx represents a vertical stretch by a factor of a and a horizontal stretch by a factor of 1 over b. Why do they have absolute values around the a and the absolute values around the b? Because your a and b can be negative, but does that affect my vertical stretch or my horizontal stretch? No, if my A is negative, I have a reflection in the x-axis. If my B is negative, I have a reflection in the y-axis, right? But my horizontal and vertical stretch are always positive. So that's why they have the absolute value on here, so it gets rid of the negative sign if there is one. Use the following key features to sketch the graph of sinusoidal function. So you need the max and the min. You need the amplitude, which is 1/2 the total height of the function, or you can use this formula. Okay? Some people get the formula mixed up with the D formula, though, so it's a bit of a mess. Your amplitude literally is just if you count from the minimum to the maximum and divide by 2, that's your amplitude. Amplitude is always what? What's amplitude always? Sine-wise. No, sine-wise. What's your amplitude always? Positive. Amplitude is always positive. Amplitude is a distance. It has to be positive. The amplitude is given by the absolute value of A. Where did that go? Come on, join us. All right, the amplitude is given by the absolute value of A. Now the period and the B value. Remembering this, period stands for what letter? Period stands for what letter? P, and in the equation, the variable you put in the equation is a B, is it not? Is B the same letter as P? No. So is period the same as B? No, because it's P. P does not equal B, and B does not equal P. Do not put the period in your equation directly. You can't. So if you want to find the B of an equation, you can switch them out. You can go B equals 2 pi divided by P. You can use the period to get your B value, and you can use the B value to get your period, but they are not the same thing. You use them to get each other, but they're not the same thing. Do you think they'll have the answer where they put the period directly into the equation as B? Absolutely. And if you don't know that, you're going to get it wrong. All right. So state the amplitude, period, midline. Midline is a line, so it's a y equals line. It's the line that cuts your graph in half. Max, min, domain, range of each of the trigonometric functions. Amplitude is always positive. This one I'm going to add something to the back, like +4. Okay. What's the amplitude of an equation? When you look at an equation, what's your amplitude? It's the absolute value of A. So it's the absolute value of 5, which is 5. What's this one? What's my amplitude? 1/4. What's my amplitude for C? 3, because it's the absolute value. What if I have a graph? What's my amplitude? So this crosses at the same spot as this, right? So this would be half the way, not the full way. So it would be 1.5, which is what? Which is half of it, which is my amplitude, right? Amplitude is half the distance, correct? I know half the distance. So my amplitude is 1.5. What's my amplitude of this one? 1 to 1, which is how much? 2, and then half of that, so it's 1. So amplitude, that's what it is for all of them. If it's an equation, you literally just pick the A value, take the absolute value of it. If it's a graph, you calculate half the distance from the minimum to the maximum. Okay, then it asks for the period. Off of an equation, the period is found by doing what? On a graph, the period, you would look for it. But on an equation, how do you get the period? Yes. We'll do 2 pi for this one. 2 pi over B. What's B in this case? It's 2. So if you look here, it even gives you the letters. A, B, C, D on your equation, on your formula sheet. So B is found between sine and x. So if you forget which one is B, C, or D, they give it to you. Look it up. So B is 2 in this case. So this graph repeats itself every pi. This one will do 360. So period equals 360 divided by B. What's B in this one? 1. So it's still 360. Does that make sense? Well, that's the only thing that affects a period. Period is the x values. What would cause that to change? A stretch. What kind of stretch? Horizontal stretch. So this one doesn't have a horizontal stretch. So it was originally 360. It's still 360. If you horizontally stretch it by a factor of 2, it's going to make it twice as long, right? If you horizontally stretch it by a factor of a half, it's going to make it half the distance, right? Do you need to know that? Just plug it into your formula, right? You could even get away with it that way. How do I know to use degrees here? I just felt like it. The only way you really know is if they give you the domain to fill it in to find it, or if your C values in degrees or radians. So this one's going to be 2 pi divided by what? Half, which makes it be 4 pi. Why is it double? Because you're dividing it by a half, because the horizontal stretch is what? By a factor of of 2. Because remember, it flips your horizontal stretch. So you're actually stretching it by a factor of 2. So it's normally 2 pi. It's now going to be 4 pi. What's the period of this graph? I know from here to here is 3 pi. But is that the whole graph repeating itself? No, it's still going to have to do that. So what's your period going to be? 3 pi times 2, which is 6 pi. We just went past a max. We're going to have to go past a what? Min. Have we went past a min yet? No, this is halfway. Okay, what about this one? A max to a max is also a period, right? Max to max or min to a min. Then I asked you for the midline. What's the midline of A? Midline's the line that cuts the graph in half. It's also y equals d. What's my d in this case? 0. The median value would just be 0, but the midline is y equals 0 because it's a line. What's the midline of B? What about C? I added a 4 so that didn't just all of them were just 0. Okay. On a graph, if you count down the amplitude and up the amplitude, you'll meet at the middle, which is your midline. So in this case, if I count down 1.5, it's actually cut at y equals 0. Remember, off of a graph, you could also find the average between the two, which is max plus min divided by 2. If you're someone who liked the formulas, they're still up here. So to find the midline, you could use this formula, max plus min divided by 2. And it can be positive or negative because your midline, the line that cuts the graph in half, could be in the negatives, correct? It could be down in y equals -3, so it can be negative. Your amplitude, though, is the absolute value of max minus min because your amplitude has to be positive. So if you like the formulas and that's the route you want to go, know it. Memorize them. Don't get them mixed up, though. That causes bad things. Okay? And then this one, the midline would be y equals, what's the line that cuts this one in half? Down 1, up 1, 0. Is it always 0? No. The whole graph could be shifted down, right? So it's y equals 0 in this case. What else do I want? I want max and min values. Off the graph, max and min values are really easy. What's the maximum? 1.5. What's the min in this case? Y equals -1.5. What's the max on this one? 1. Y equals 1. Ah. What's the min? Off an equation, what's the fast way to get your maxes and mins? Remember, I told you on the previous page. D and the amplitude. I know you repeated him. But D and the amplitude. So what's the min? Min is D minus amplitude. What's the D in this equation? 0 minus 5. So what's my minimum at? My maximum is D plus amplitude. So it's going to be 5. That was fast. Okay. This one, my min is D, which is 0 plus minus, not plus. Minus a quarter. So it's -1/4. My maximum is 0 plus a quarter, which is a quarter. What's my minimum of this one? No, it's 4 minus 3, which is 1. And what's my max? 7. 4 plus 3. Now, why are the min and the max helpful? Yeah, your domain is going to be XCR. Your range is going to be min to max, right? So they don't have to ask you for the min and the max. They can just ask you for the range, which is indirectly asking you for the min and the max, correct? So the domain of each of these, every single one of these has a domain of XCR. Unless they restrict them. Remember how many times they restrict domains? Other than that, yeah, it's XCR. But they're not going to ask you for a restricted domain if they give you a restricted one. So technically, if they're asking you for a domain, it's probably XCR. But they often ask for ranges because those are harder to do. So what would the range of this graph be? If we do in set notation, it's going to be y such that minimum -5 is less than or equal to y is less than or equal to, both these are else, 5 YER. If we do it in interval notation, it's even easier. Square bracket -1/4, square bracket 1/4. Remember, you guys really need to know if they're equal to or not equal to's, because they'll just get the same answer with round brackets, right? And if you don't know, you're going to be 50-50 guessing. Now you know it's equal to because that's the minimum and the maximum. If it's not equal to, you'd have open dots on the min and max. Do we have open dots on the min and max in all of our sine and cosine graphs? No, they equal those. So there's an equal to sign. And then this one, if you do set notation, it's going to be y such that 1 is less than or equal to y is less than or equal to 7 YER. And then this one, -1.5 to 1.5. And this one would have a range of -1 and 1. Okay? So they can just ask you stuff about a graph or ask you stuff about an equation, and you need to know the difference. On an equation, your amplitude is the absolute value of A. On a graph, your amplitude is half the distance from the min to the max. On an equation, your period is 2 pi divided by B, or 360 divided by B. On a graph, it's how long till it repeats itself. On an equation, your midline is your D. On a graph, the midline is the line that cuts the graph in half. And you need to know the differences. Okay, transformation. Now, determine the transformations on a y equals sine x or y equals cos x given the following transformed equations. Remember, horizontal translations are called horizontal phase shifts, and vertical translations are called vertical displacement. So only in trig do they change them to vertical displacement and horizontal phase shift. Here's your 4 equations. I want you to state the transformations. Give her. Please tell me, on the diploma, you will do this. What do you need to do first before you explain? Take out the half. And when you take a half out, what do you have to remember to do? When you do 45, yes, that. -5 sine 1/2 x minus 90 plus 15. When you divide by a half, it's like multiplying by 2. So we have a vertical stretch by a factor of 5 about the x-axis. We have horizontal stretch by a factor of what? 2 about the... We have a reflection in what? Reflection in the x-axis. We have a vertical displacement, 15, up, horizontal, phase shift, 90 degrees, right. What do we have to do with B? Take out the 2, y equals 0.1 cos 2x plus 45 minus 1. So we have a vertical stretch by a factor of 0.1 about the x-axis. We have a horizontal stretch by a factor of 1/2 about the... Are there any reflections? No. Vertical displacement 1 down. Horizontal phase shift 45 degrees left. This one, the 0.5 is taken out already. If it makes it better for you, put brackets around the whole thing. Go for it. You have a vertical stretch by a factor of 5 about... You have a horizontal stretch by a factor of 2 about the... You have no reflections. You have a vertical displacement 3 up. Horizontal phase shift pi left. This one, you have a vertical stretch by a factor of 2 about the x-axis. You have a horizontal stretch by a factor of 1/2 about the y-axis. You have a reflection in what? X-axis. Vertical displacement 4 up. Horizontal phase shift pi over 3 right. Writing equations is where life gets a little bit more complicated. So when we write equations of graphs, our A's are the same, our B's are the same, our D's are the same, whether it's cos or sine. It's the C that changes depending on if it's cos or sine or negative or positive. So write an equation of each sine function in the form y equals a sine b x minus c plus d given its characteristics. So it has an amplitude of 2. So we would have y equals plus or minus 2. Right? Sine pi x, is that what I do? Because that's the period. Is period B? No. So B equals 2 pi divided by period, which is pi. So B is actually 2. X, a phase shift pi to the left. So plus pi. And you have to put it in brackets if it's correct. And then the vertical displacement 2 up plus 2. Now, either plus or minus 2 could be a possible solution, right? They would have to say A is greater than 0 or A is less than 0 if they want a specific one. Now, this should not say sine. It should say cosine. And this should be cos. So what if they changed it up and asked for the cosine function in the form y equals cos bx minus c plus d? What would change? Yeah, the horizontal phase shift. Yes, the cos would change. It's changed. The horizontal phase shift. Because cos and sine are just a horizontal phase shift away from each other. So the C value. I'm scared I wasn't recording. Okay. So we're going to come up with equations, and you're going to pay close attention so I don't lose you. Okay? So we are going to come up with 4 equations. How do we know which one they actually want? Well, the multiple choice answers would give it away. One of them will work. The other way is they could say an equation in the form y equals a cos bx plus c plus d, where a is greater than 0. So they tell you if a is positive or negative and what graph they want. Okay? We're going to find all 4 so that on the test you could find all 4 if you needed to. So we're going to have y equals, y equals, y equals, y equals. You're going to have a positive sign, positive cos, negative cos. Okay. The first thing we need is the a value. Where do we get the a value from? Amplitude. The amplitude of this graph is what? Of every graph is positive. That is true. That is not what I was meaning. It's 8 from min to max. That's true. But what's my amplitude? It's 4. So it's 8 divided by 2, which is 4. So on all of my equations, I'm going to have plus 4 sine, minus 4 sine, plus 4 cos, minus 4 cos. The next thing I need is the b value. How do I get the b? From the period. So it's going to be 2 pi divided by p. Why is it 2 pi and not 360 in this particular question? Because the x-axis is in radians. How long does this graph take to repeat itself? So you could count from max to max, you could count from min to min, or I'm going to count from the y-axis, past to min, past to max, back to that same height, which is 4 pi. You're correct. So it's 2 pi divided by 4 pi, which is a half. So for every single one of these equations, I'm going to have a half x something, a half, bracket x something, a half. I'm going to do the c last because that's the only thing that's different. The d is the midline. I could go max plus min divided by 2 and get my midline. I can use my formulas, right? It's an equation, it's a graph. I can use my formulas. Or I can count down. So I can count down 4 for my amplitude. I can count up 4 for my amplitude. And where are they meeting at? Yes, y equals 1. So your d equals 1. So we're going to have plus 1 at the back. You need to draw your midline. Why do you need to draw your midline? Which equation does it help with? Well, this is just not very good at all. I'm going to try that again. No. Try again. Other one. Sine. So what we do is we look for the closest intersections with the midline and the graph to the y-axis, the closest ones. Those get you your sine translations. Why do those get you your sine translations? Because sine on the original graphs, midline crosses through 0, 0 when it's on the way up, or 0, 0 when it's on the way down if it's a negative. So, which ones have positive slope? This one and this one. So those are going to be the distance of my positive sine. Okay? So I can either say 2 pi to the right, or in this case 2 pi to the left. Either of those answers could be there because they're equal distance from y. So remember, it's supposed to be here, correct? Is it here? No, it's 2 pi to the right, or that cross is 2 pi to the left. So I'm just going to go plus 2 pi. Could you have went minus 2 pi? Absolutely. Then where that intersection happens, but with a negative slope, is for the negative sign. How far away from 0 is that little intersection dot? 0. So does it shift at all? No, this one's done. Could you go plus 0 at the back? Sure, but it's done. Close graphs are the easiest to find. Sines, you have to have the midline, you have to find out where they intersect, you have to find out how far away they are. Close graphs are way easier. Positive close graph, you look for the closest max. Negative close graph, you look for the closest min. Way easier. Because on a positive close graph, your max is on the y-axis. Is my max still on the y-axis? No, it's pi to the what? Left from the y-axis. So my positive cos, I'm going to go minus pi. Oh, sorry, plus pi. Pi to the left. And my negative cos, I look for my closest min, because when it's a negative cos, min is on the y. Is it on the y? No, it's pi to the negative pi. And I have all 4 equations. And now they can ask me for any of the 4, and I can do any of them. You don't want to just be able to do the coses, or you'd be in trouble if they ask for sines, right? Now, how can I check and walk away from this question and know I'm completely correct? You were right. Oh, it's 4.0. I was even asking it. I was counting it. I don't ever use the formula. No, if I count it, I'm fine. I don't like the formula. That's disappointing. That's a lot of rewriting. Dun, 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 dun. So if I count the 2.2 down, where do I get to? Or the 2.2 up, I guess. Yeah. And where does that get me to? Yeah. Right here, I think. When you count 2.2 down and you get to 1.8. That's a minus. The period of this graph. I really like sine. It's my favorite. I really don't know. I just really wanted to write sine a whole bunch of times. Okay. The period is pi. So b equals 2 pi divided by pi, which is 2. Okay, sine. We look for the closest going upward one. What would that be at? How much is every tick worth? How do we remember? How do we do that? Remember, you go to pi and you count the number of ticks. 1, 2, 3, 4, 5, 6. So each tick is actually worth pi over 6. So this tick would be worth pi over 6, but it's halfway. What's half of pi over 6? Yes. So it's to the left pi over 12. So we're going to go x plus pi over 12. Now this one, this would be pi over 6. This would be 2 pi over 6. This would be 3 pi over 6, right? I want the halfway between them. So I want the average. How do I find the average or halfway in between them? Add them up and divide by. So 3 pi over 6 plus 2 pi over 6 divided by 2. So I get 5 pi over 6 divided by 2, which is 5 pi over 12. So I'm going to go x minus 5 pi over 12. The cos and the cos positive and cos negative are easiest to find. The closest maximum is pi over 6. So I'm going to go x minus pi over 6 because it's pi over 6 to the right. And the closest minimum is pi over 3 to the left. You have to be able to find those c values on the sine, though, and know to divide and stuff like that. Because that's a challenger. Then flip over. We're going to go over tan information. All right. Tan graphs are very, very, there's a very small amount of information that gets put on tan graphs, but they do appear every so often on the diploma, so we're going to go through it. A tan graph does not exist. A basic tan graph is undefined at 90 and 270. Why is that? Because the y is 0. No, not the y is 0. Close. Other one. X is 0. When you do tan, it's y over x, correct? when x is 0, we get undefined spots, which gets us asymptotes. So that's why our asymptotes are at 90 or pi over 2 and negative pi over 2, 3 pi over 2, negative 3 pi over 2, etc. Okay? If tan is negative, you just end up getting a reflection in the x-axis, so you get curves that look like this instead. Okay? So tan graphs, unlike sine graphs and cos graphs, repeat themselves every 2 pi unless they're stretched horizontally. Correct? So every 360 or every 2 pi, cos graphs repeat themselves. Sine graphs have a period of pi or 180. Big difference. So the period equals pi divided by b, or the period equals 180 divided by b. So if they give you a tan equation and they ask you for the period of the graph, you would not fill it into 2 pi over b, which everyone does because they're so used to it. So if they gave you an equation like tan y equals tan 3 theta, what would the period of the graph be in radians? You guys ask this all the time. If they give you y equals tan 3 theta and they ask you for the period, what would it be? Why 4? Where are you getting 4 from? There's not even a 4 on this page. There's not. Like down here? Oh, goodness. No. All right. So what you need to remember is that tan graphs, please listen, tan graphs repeat themselves every pi over b or 180 over b. Only tans. Sine and cos are 2 pi and 360. That's the biggest difference. You can plug them into your calculator and see. A horizontal stretch would move these graphs over, wouldn't they? So a horizontal stretch would change your x-intercepts on a tan graph, and they would change where your asymptotes are, because it would stretch the graph further. Yeah. Well, that would just be the same graph, because it would just move this whole thing over, because the graph repeats itself every 180, right? So if you just shifted it 180, it's just going to land it back on top of each other. At your 90 or 270, the only time it changes is if you have a horizontal stretch and it changes the graph, right? Okay. That's tans in a nutshell. Then we have left word problems. This is huge that you know these words, because these words give you what your A's and your D's and your P's and stuff like that are. The diameter is 2 times the radius, which is the radius is the amplitude. So if they tell you the radius, they've told you the amplitude. If you don't know that, life is a lot harder. Radius is half the distance from the center to the edge, right? Amplitude is half the distance from the center to the edge, is it not? So radius is amplitude. Center of the wheel. If there's a wheel, the center of the wheel is the midline. It's the line that cuts the graph in half. It's the line that cuts the wheel in half, right? So your midline is the center of the graph. 1 revolution or rotation is the period of the graph. If you know those words, these questions are a heck of a lot easier. So I always sketch it. If you sketch it, life is easier, because if you sketch it, it gets you the C's of all of the sine and cos graphs. Okay? So the London Eye has a diameter of 122 meters. This is not to scale, because I just drew that really large. Anyways, this is just really bad. This is just getting progressively worse. We're going to put that there. Okay. Anyways, this has a diameter. We're going to split it into 4. It has a diameter of 122. So what's its radius? How can we figure out what the little base is? 135 minus 122. So the maximum height is at 135 meters. That's always your y. The distance up to there is 122, and then to the ground, right? So if I go 135 minus 122, what's my base? So the base is 13 meters, we agree? So this point is 13 meters, 13 meters. We don't know the x's yet. What is the coordinate here at these ones? What's the y? 13 plus 61, which is 74. That's the center of the circle, isn't it? So that's your d value. How do I find all these x's? Those are the times. So the period, how long does this thing take to ride around? 30 minutes. And I'm cutting it into 4. So if I go 30 minutes divided by 4, if I stopped at each of those spots along the way, how much would it be? 7.5 meters or minutes? Is it minutes? So this would be 0 minutes. I get onto the Ferris wheel. This would be 7.5 minutes when I reach the midline, correct? On the way up? On the way up, I reach the midline at 7.5. This would be 15 minutes when I reach the maximum. This would be 22.5 minutes when I reach the midline on the way down. And then this would be 30 minutes when I reach the bottom. We agree? So we're going to come up with the 4 equations. What's my amplitude? (61), it's the radius. So plus 61 minus 61 plus 61 minus 61. Sine, sine, cos, cos. Okay. What's the period of this graph? 30. What's the b of this graph? 2 pi divided by 30. Why is it radians? Word problems are always in radians. That's why. So we're going to have pi over 15. Pi over 15. What's my d value? What's my d value? 74. The center of your circle is D, because it's the midline. It's the line that cuts the graph in half. Remember, the graph does not include this base. If I drew this graph out, I would start at 0 and 13. I would go up to 135. I would come back down to 0 and 13. I would go up to 35. So what's the lowest my graph goes to? 13. What's the highest my graph goes to? 135. What's the midline? 74. Right? It's literally this graph, just periodic. So the minimum, the closest minimum is my cos, my negative cos. We agree? What's the x? Because that's the x is the c value. How far away is my minimum on the x? My minimum. 0. My minimum cos, so my negative cos is just x. There's no translations. What's my closest maximum? And remember, it's the c value is always my x. 15. So my positive cos is going to be x minus 15. Which one of these is the sine? 7.5 or 22.5? Both of them. Which one's the positive sign? Because it's on the way up, and then 22.5 is on the way down. So I'm going to go minus, x minus 7.5, x minus 22.5. Any of these 4 would work. So pick one of them and punch it into your calculator. Which one would I use? The fourth one. They're all minus because they're positive time. So they'd all be to the right. So I would type in negative 61 cos pi over 15. What mode do I need to be in? Because I pressed the cos button. Yeah. Need to be in radian. So type it into your calculator. You're going to get negative 61 cos bracket. I'm going to go alpha y equals, and I get a fraction. Pi divided by 15. Open bracket x, close bracket, plus 74. Now, I need to set a window that works. I know that this graph repeats itself every how much horizontally? 30. So I'm going to make my x min be 0 and my x max be 60 so I can see it rotate twice. X scale, make it be 10, sure. What's my minimum of my y here? The minimum of my y, you could put 12. I'm going to put 0 because I'm going to count it at ground level. What's my y max at? 135. So I'm going to go 140. I'm going to make it go up by 10s. Now I should be able to see. That is awesome, that bird out there. I can't see it. I get a horizontal line. I must have screwed up. What do I need? The mode in radian. Oh, look, there it is. The brackets were there. It just was in the wrong mode. Okay, I want to know the second time the passenger is at a height of 128. Did they give me y or did they give me x? 128 meters. They gave me y. So I go to y2 and I put in 128 and I find out the second time it intersects. Second trace 5, go closest to the second intersection. Enter, enter, enter. And my x value is 17 minutes. How high is the passenger at 12 minutes? What did they give me? The x. So second trace value, x equals 12. 123 meters. Okay? Example 2 we'll leave for now. So that's graphing.